Order for Polly Marcus.
Look at that. Pottery, the original disposable. What was just comically represented a few minutes ago was the world's first purpose-made disposable cup. Found in Crete, the ceramic solo cup dates back 3,600 years. While not all pottery was created to discard, the innate qualities of ceramic make it the most common and widespread archaeological artifact in the world. Like future archaeologists will probably look at plastics from our current era, modern archaeologists find an overwhelming amount of pottery from ancient. Because of the delicate process of shaping and firing pottery, as well as the brittle nature of the pottery itself, it means it was constantly being created, destroyed, and disposed of. When we fast forward to modern times, what do archaeologists do with these shards? While pottery gives insight into the lives and practices of the people being studied, it also makes a great sample for thermoluminescence dating technology. Developed in the 1950s, thermoluminescence dating uses energy stored in minerals within artifacts to shed light on their creation. As the name implies, thermoluminescence involves the relationship between heat and light to date materials. Rock minerals like quartz or feldspar that are found in many artifacts are crystalline minerals. Crystals are formed when atoms form lattices, or a series of regularly repeating patterns. Over time, these lattices collect electrons exposed to them in the form of radiation through the Earth or the Sun. When the crystal is exposed to intense heat, the accumulated electrons become excited and escape the lattices in the form of a flash of light. It is this flash of light that can be used to measure the date of a sample. Because when the crystal is heated and loses all extra electrons, the date at which the artifact, like a pottery vessel, is fired can be used as like a reset button on a stopwatch. The rate at which the crystal absorbs radiation can be measured in annual doses from the surrounding area. Because each dose of radiation emits a specific amount of light, measuring the amount of light released means scientists can work backwards to determine the number of annual doses, and therefore years, the samples collected since the last heating. This method inevitably has its strengths and weaknesses that should be taken into consideration. One of the most valuable considerations is that this method is able to be used to date objects that are much older than dating methods like radiocarbon or uranium-thorium. Thermoluminescent dating is also extremely useful when it can be used to analyze samples that cannot be tested using those methods. Dating accuracy of thermoluminescent dating provides samples accuracy within 10 to 15% margin of error. This method is also fairly affordable, costing only $200 to $300 per sample. There are concerns associated with this technique as well, mostly concerning the possible fluctuations in confounds regarding exposure to radiation. Also important to consider is the cost of testing the sample itself. Heating the sample can potentially damage it, as well as rendering it useless for future testing. In the end, thermoluminescence provides a valuable tool when it comes to dating archaeological artifacts. While not the most accurate, this method can be used to verify and authentify the dates of artifacts in conjunction with other methods of research.